So lesson number 1, geometry.
This is the IB Math Applications and Interpretations SL Practice Paper 2, question number 9.
Hello. Before we begin, don't forget to put your calculator in degree mode. This is very important.
It got cut off, but it's important to put your calculator in degree mode because we're measuring the angles in degrees.
Okay, to start off with, I've already written most of the information we needed. I have filled in our little diagram here with our square-based pyramid with the information we need, with the height of 50 from the center of the base and the sloping angle with the base of 75 degrees. So the first part of this, part A, is to find the length of the sloping edge. So how we're going to do that is we're trying to find this big hypotenuse here. And what we can do is we can break up this triangle so that we can we only are focusing on one part of it instead of the whole. So if we come over here, I'm going to redraw this triangle shape over here. Okay, now, so we know that the height of it is 50 because of this height there. Then we know that this is 75 degrees because of this. And then we're trying to find this x. Now, we also can find the angles of all three of these. So we know that this is a right angle because they meet at the center of the base. So that's 90 degrees. And then this, we're trying to find this little
Angle.
gap here. So 90 plus 75 is 165, and then 180 minus 165 is 15. So that means that this little angle up here is 15 degrees. I'm writing it outside of the triangle because I don't have enough room to write it inside, just so that you know. Okay, now from there, if we're trying to find this hypotenuse, we can use the sine rule because, as you know from SOHCAHTOA, sine equals opposite over hypotenuse. So we're going to do the sine of 75 equals 50 over x, okay? Except we're trying to get x by itself because that's the hypotenuse and that's what we really want to know. So we multiply both sides by x and we get x sine 75 equals 50. But again, that's a 50. But again, we're trying to get the x by itself. So then we divide both sides by the sine of 75, pardon the handwriting, and we get x equals 50 over sine 75. So then if we plug that into our calculator, 50 divided by sine of 75, close parentheses, equals 51.76. So we're going to round that up to 3 significant figures because that is what IB prefers. So then that is our answer for that part. 51.8 centimeters. Don't forget to always include your units because they're what you're working with. You can't leave out what you're working with. Okay, so now we're on to part B, which is the length of the diagonal base. So we're trying to find this whole length. We can actually use this triangle that I have previously mentioned to help us. So I'm going to switch colors just so that we can differentiate. So for part B, we are going to use the tangent because we found this. This is now 51.8. Okay, now we're trying to find this x. So we know from the tangent rule that it's opposite over adjacent, right? And if we're trying to find this part, so we can find this whole diagonal slope, see how these match? We're trying to find this x, so we would have to do the tangent. So I'm going to come over here for more room, and we're going to do tangent of that 75 equals 50, because it's the opposite, over the x of the adjacent. Again, as we did in the side one, we have to get the x by itself, so we're going to multiply both sides by that x. So we get x tan of 75 equals 50. Divide both sides by the tangent of 75. Okay, and then we do, so we get x is equals the 50 over tan of 75. Okay, now we're going to plug that into our calculator. So we get 50 divided by the tangent of 75, close parentheses, equal. So we get 13.39, which we are going to round up to 13.4. Again, we're rounding because we need 3 significant figures. I already mentioned that. So we're going to do 13.4. Okay. Now, the 13.4 is only half of the base because we only found up to the middle. So, in order to find that, well, to multiply by 2. And 13.4 times 2 is 26.8, which concludes part B. So I'm going to fill that in, 26.8 centimeters. Okay, now we're on to part C, which is the total volume of this whole square base pyramid. So actually what I'm going to do is I'm going to fill in this 26.8 here, just so that we can get the full picture in our brains and we know what's happening. Okay, so now we're on part C, which is the volume of the whole square base pyramid. So the volume formula for a square base pyramid is 1/3 the area of the base times the height. So I'm going to first try to get the area of the square base. So I'm just going to draw a little picture of that separately. And so we know that because it's a square, it will have 4 90-degree angles. Now, we already know that the diagonal of this square is 26.8. And we can actually use this 26.8 to our advantage when trying to find these side lengths. Because ultimately, we're trying to find the side lengths, which will give us the area of the square base, which is our A. So, because it's the hypotenuse, we know that it splits the 90-degree angle directly in the center. So we know that this is a 45, 45, 90-degree triangle. Because of this, we're going to take our 26.8 and divide it by the root 2, because we know the hypotenuse equals side of root 2 for a 45, 45, 90-degree angle. So the hypotenuse we already know is the 26.8 equals sine of root 2, and then to get the s by itself, divide by root 2, divide by root 2. Okay, so now we already have this. Okay, so from this I get 26.8 over root 2, which we know is one of the side lengths. But since we know that all of the side lengths are going to be the same because it's a square, we can square this whole thing. So if we plug this into our calculator, 26.8, oh my goodness, okay, divided by the square root of 2, close parentheses, squared, you get 359.12. And now we're going to do 3 sig figs, so we get 359. Okay, and that's the area. That's the area of our base. So then we plug that into our volume formula. We get 1/3 359 times 50. I personally, when I'm doing this type of thing, I do the whole numbers first and then I divide by the fraction. So I will do 359 times 50. And then I will divide the number that I get divided by 3. And I got 5,983 0.33, but to three significant figures. 5,980 centimeters cubed, because it's volume.
Hello. So you may have gotten slightly different answers than me. I chose to round as I go. However, IB chose to round all at the end. That's the only difference. Thank you for watching. I hope this helped.